Good evening, all the aspirants present here. We'll be starting with the session. The topic for today is epidemiology, and it is the class 2. And the speaker that we have here is Dr. Naveen Kumar Shiv. He is a senior resident neurology at JB Pan Hospital, New Delhi. So, more aspirants will be joining us. Thank you.
Good evening, everyone. So in the last class, I think we have seen about the type of studies, RCT, case controlled cohort, and the bias which can affect the studies. So moving on to the part two, we will be analyzing how to get the data and what are the tests we will be using to analyze the data. So these are the topics that we'll be covering today. And just note that I will just mark the very important, the frequently asked questions. So the null and alternate hypothesis, confidence interval, forest, and the data test used for the data. These are the frequently repeated questions, okay, and the skew distribution. So we'll go on to the proper class. So once you do a study, you'll be getting a data. So how will you categorize the data? So the data can be observatory, like qualitative, or it can be quantitative data. So what do you mean by qualitative data? So you're doing a research or you're doing a study and your aim is to find what is the how many patients are smokers. So now you will get a whether they are smoker or non-smokers. So it is mostly a binomial, like whether you can put it in this category or that category, and it is not structured by nature. So for example, for this is like if you want to divide the groups according to the eye color, if you want to see the iris color and say that they're green and blue, so it will be mutually exclusive and you have to put it in either two of the categories. So these are the qualitative data. Once you get the qualitative, the quality, because it is you're seeing the color of the iris, you're not seeing any number per se. But once you get the data, you will have a data. For example, there will be 50 people population with a green iris, and there will be 20 with blue iris. So though you get number, but the exact variable you are looking is the color, which is a qualitative data. So these are the qualitative data. So once you get, you do divide them into a nominal or a ordinal data. So what is a nominal data? So nominal data is, as I said, it is whether it is male or female, color of the iris. So we're dividing into that. And there is no particular order to divide those data categories. For an ordinal data, you can have scales. A typical example is that you go to a restaurant, they ask you whether you're satisfied, you're not satisfied very much. So there is a level of satisfaction that you will be grading. So that becomes an ordinal data. The quantitative data, you are looking for the number per se. For example, you go to a class and you segregate what is the percentage of the students above 150 centimeters and below 150 centimeters. Once you use that, you are looking for height, which is a number. So that becomes a data, quantitative data. So the discrete data, you can divide them into groups and then you can collect data. Like for example, though the height distribution is continuous, like it starts from maybe 110 centimeter in a class, it can be till 200 centimeters. So it's a continuous data, but you can make that continuous data into discrete data by dividing them into particular groups. For example, you can make 100 to 120 centimeters on particular group, and 120 to 150 on particular group, and 150 to 180 on particular group. The continuous data can be made discrete data by dividing them, but it's okay. So we will just go into the examples of a nominal data. So this is just an example showing that what is the distribution of the population according to the political party supporters. For example, there can be only three. So just for saying it is a US data, whether they are Democrats or Republicans or independent. So either you have to put only the three categories or nothing else, and you are looking whether they are looking into the quality. You are not looking into the number per se, whether they are Democrat or Republican. So this is a categorical nominal data. So what is a categorical ordinal data? So once you classify them according to a particular scale, and again you can see that it may mimic like a discrete data, which is a quantitative data. But the criteria here is that you don't have a well-defined interval between these. You are just arbitrarily assigning those into 5 categories. There is no well-defined intervals between them to define them. So this becomes an ordinal data, and you can get the proportion. With this proportion, you can do further analysis, which we'll be talking later. So the other one is a new discrete data, which I was saying. So you can provide a cutoff. You can see there's a specific intervals of 5. And for each group, you are calculating the number. The percentage of fat is a number. So it is a numerical data, which is a quantitative data. So you're dividing them into a particular definitive groups based on the interval. So once the interval is well defined, you put them into a discrete data, and also think that these discrete data contain zero. Like the quantitative data contains the value zero, absolute zero, meaning that that can be 0% of, though it is hypothetical in this case, it can be zero. So these are the data types. I'm just consolidating it. So once you get the data, it can be a qualitative data or it can be a quantitative data. So the typical examples for qualitative are nominal, which it is marital status. Once you do a survey, married or unmarried, either there can be only two categories, and there is no weld, and it is occurring in nature. High color. So these are some examples of a nominal. Qualitative data, you divide them into a particular groups, but these groups doesn't have a well-defined interval. It is arbitrarily assigned. Then the other, coming to the quantitative data, discrete data, I just told you, just show the image. The other example is number of hospital admissions. So you can put that group A or the number of hospital admissions. You can say that one greater than 5 admissions, greater than 10 admissions. Then you can see how many patients are coming. For example, there are only one, this is the y-axis, this is 5, this is 10. You plot like this, and then you analyze it. So you have a particular well-defined interval that defines the discrete data. Continuous data is blood glucose level. It can be ranging from any value. There is it can be an integer or it can be a decimal points as well. Mostly the discrete data are complete integral. Like it can be a number, it cannot be in decimal. So going to the specific statistical test, see, this table is very important. You will definitely get one or two questions from the test which are used for particular data. So first we will see the continuous data. So for the first, we will take an example. So you're comparing the BP, systolic BP in smokers versus non-smokers. So what will you do is that you take the mean of the systolic BP in the smoker and you compare with the mean of the non-smokers. So since it is normally distributed, systolic blood pressure is a continuous distribution and they are normally distributed. I will be discussing what is the criteria for normal distribution. So once it is normally distributed, you apply an unpaired t-test. You apply an unpaired when there are two independent groups. This is very important, two independent groups. You apply the unpaired t-test. They will not be asking you about the formula, or they will be asking about the particular, what is the value, t value. They will not be asking that. They will just ask you whether you are confident which test is used for what type of data. So two independent is unpaired test. When you are comparing the same groups, for example, you are taking 100 females and you're giving iron tablets, you are comparing the pre and post intervention hemoglobin levels. So you're doing it in the same group. So that becomes a paired t-test. So when you're having more than three groups in the data, continuous, for example, you're dividing the group into three. Okay. So now you can use ANOVA. Okay. This is one of the tests. They will not be asking you about the exact formula, whatever. Just remember it will be ANOVA test. So when you're having two continuous variables, for example, I'll just show you what are the two continuous. So for example, let us assume this is the, sorry, I'll just check this. Let us assume this is the BP, the x-axis. And the y-axis, sorry, let us assume this is the weight. And the y-axis is let us assume the BP. So these are two continuous variables. The weight is also a continuous variable. The BP is also a continuous variable. When you are comparing between the relationship between the two variables, then you use a test called as Pearson's correlation. When you think that data is linear, you use a Pearson's correlation. When the data is kind of skewed like this, you use a Spearman's coefficient. Okay, just remember the terms. That's it. They will not be asking you about the formula or we will be discussing about the Pearson's correlation in detail after a while. Just coming back to this. So when you are looking into two continuous variables, you use a Pearson's correlation. So for example, typical example is height versus weight. When you are having for example, a row also I have told you, when that is a non-linear, it is not straight, you do a Spearman's correlation. Example, CRP and ESR. There are some inflammatory where CRP will be too much raised, ESR will not be raised that much. So that when the distribution is not linear, you tend to use a Spearman's coefficient, a row coefficient. There is another test, man-Whitney U. This is a frequently asked question. So for example, when you have a continuous data, but it is not normally distributed, we'll be discussing it later, what is not normal distribution. Then you use a man-Whitney U test for comparing the means, okay? So this is frequently asked question, this man-Whitney test and this ANOVA. So just make sure that you are just looking into the examples. So continuous variable I have said is. So the Pearson's correlation, when you're using a two continuous variable, I just said, for example, this is the weight and let us assume this is the blood pressure. So you can see that in this curve, the figure A, I just labeled it as, whenever there is a linear relation between the rise in weight and rise in blood pressure. So what we can conclude is that whenever the weight is rising, the chances that BP is also rising. So what is the R value? This is slope. We need to calculate the formula. When R is 1, the correlation is 1. It will be a straight line like this. When it is negative, matlab there will be, whenever the X variable is increasing, the Y variable will be decreasing. So this is the example when R is -1. When there is no correlation at all, like the X axis and the Y axis are not related with each other, then there R is 0. So depending upon the slope, the R values will be calculated. We just remember that when R is +1, that's a perfect correlation. When R is -1, there is a negative correlation, meaning that whenever the X variable increases, the Y variable tend to decrease, vice versa it is. Okay, so this is Pearson's correlation. Just remember R this. So coming to the quantitative data, I was talking about the nominal data. For example, if you want to compare what is the gender distribution between two groups. For example, you see male, you see female, and you just want to, what is in group A, what is the number of females in group A? You want to compare with the sex distribution in group B. You use chi-square test. Okay. So how is the chi-square table? I'll just show you the table alone. Just remember the table. So this is a contingency table for a chi-square test. So you know that we are doing it for this in this particular example. What we will do is that we will see how many are HIV positive and HIV negative, male and female. So you form a 4x column, like you have a 2 rows, then you have 4 cells in each. So once you have 4 cells, you have to analyze it. If any of the values is less than 5, then you use another test. Okay. So when all the values are more than 5, so you use a chi-square test. Then if it is less than 5, any of the value in the cells are less than 5, you'll be using a Fisher's exact test. So that is what mentioned here. The frequency is less than 5, use a Fisher's exact test. Okay. So this can be frequently asked, chi-square. Chi-square, you will be comparing between the proportions. For example, you will be putting like this: cancer plus cancer minus, this is smoker plus smoking minus. So you will also again using a chi-square to see the proportion, what proportion of smokers, whether it is significant between the groups, whether smoking is causing cancer or not. So you'll be using chi-square because we are not doing continuous variables. It is kind of categorical. Either they're smoker, either they're non-smokers. So you'll be using these tests. Whenever ordinal, so I told you that ordinal is kind of scale which is not well defined, which is arbitrary. So for example, there is a pain score, you write 1 to 0, like 1 to 10. There's a pain scale 1 to 10. So now you want to see what is the effect of drug A and drug B on the pain score. So now after giving a drug A, you see that the pain is reduced by 50% in group A, and group A it is reduced by only 10%. Now what you will do is that you will use a Mann-Whitney U test to see the reduction. So this is again this Mann-Whitney can be used when there are non-normal distribution. When the continuous variable, also you can use the Mann-Whitney U test. So Mann-Whitney U test can be used in two specific locations. So one is a continuous data where the distribution is not normal. And the other one is an ordinal scale, ordinal data. And the ordinal data has same group, like you want to compare between the same group, like the restaurants, you just do a baseline survey about this customer satisfaction. Then you educate about the workers there. Then you redo the study and you see what is the improvement there. Or for example, whatever it is given, what is the heart failure class in which the patients are changing after the treatment. For comparing the same group before and after, so you use the Wilcoxon's signed rank test. It is similar to the PAR-T test, right? PAR-T test in the same group. It is like a PAR-T test. So make sure that you will be definitely tested to the questions. These slide will have the tables, this table and the other table. You will get 1 or 2 questions definitely for your MRCP. Don't forget, you don't remember the formulas, you just remember what test, where it is used. Okay. So just come by summarizing what are the tests. So first you see whether the distributions are, this is categories, okay? This is categorical data. This is a continuous, like I mean continuous again means quantitative data. Okay, I just write quantitative or a numerical data. So once you see whether they are normally distributed. Normally distributed means the height, weight in the population. So if they're normally distributed, you do a student t-test. If there is a independent t-test, you do between two groups. You do a paired test to the same group. When there are more than three groups, you use ANOVA, analysis of variance. Okay, so this is for a continuous distribution. But when you're having a non-normal continuous distribution, you use these. When there is two median, you can use man-Whitney's use test. When there are three or more medians, you use Kruskal's-Wallis. And as I mentioned, you do chi-square when there is a category. All the cells should be more than 5. When any of the cell is less than 5, use a Fisher's exact test. And comparing between two continuous variables.
পাঠিয়ে দে একটু বিপিটা দেখতে হবে। হ্যাঁ চলে আসুন প্লিজ। সঙ্গে কেউ এসছে আপনার? আগে বোধহয় দেখেছি না একবার অনেক আগে। হ্যাঁ মুখ মনে থাকে আমার।
Excuse me, Mr. Ajit.
আগে মুখ মনে থাকে, মুখটা মনে মানে দেখেই মনে হচ্ছে আপনাকে দেখেছি। এই আর কি। I may be wrong.
2024 এসেছিলাম।
Mr. Ajit, can you mute your mic?
আচ্ছা আচ্ছা। কে আছে সঙ্গে? বাড়িতে কেউ আছে সঙ্গে?
অ্যাকচুয়ালি 2024
Am I audible?
Yes, sir, you are. Please continue.
Achha, is there any issues? Let me know. I'll be sharing the PowerPoint you can see as well. Okay, so don't remember, just see the tables. I have just the tables and the test which are used. So chi-square also explained it. So coming to the normal distribution, you can expect one or two questions from the concepts from mean, median, mode. Okay. So for example, I am just entering into a class, 12th, and I just want to collect the data regarding the height of the students there. So now what I'm doing is that now I have collected the data. So now I have arranged in a table. So 161 centimeters, there is one guy. 163, there is one. 165, there is one. And as I am arranging in a ascending order, and I can see there is at the height 170, the maximum number of students have height as 170. So what mean that? So anyone, do you know the concepts of mean, median, and mode? Okay, so I just example. See, what is normal distribution? So normal distribution is the distribution which occurs by nature, that you cannot have a say on it. For example, height will be normal distributed, meaning that a huge percentage of the students will be concentrated around one particular height, and there will be short and there will be tall. The most tall will be maybe assuming it 180, and the shortest would be 110. But most of the students will be having height around 170 for this, as in this case. So what do you mean by that is, like, once you plot this as a box plot, sorry, just histogram, you will say that the height 170, there are 6 students, so 7 students, so I'll be just having a bar like 7, and 167, may just giving an example, it is not the same, it is another, just an example I'm giving you. So you will just plot like this. So you can see that maximum students are distributed around this area, this height. So you can say that there are 7, 9, there is 7, 2, this is 2. So you can say there are 11 students who have the height between 167 and 172.5. So meaning that there is some concentration around the center. So this is called as what is called measures of central tendency, and we will be seeing what is the measures of deviation. So there is a tendency to cluster around a mean point. So what is the point which these are clusters are there? We tend to analyze it using a mean, mode, and median. For example, what is mode? It is most easy, most frequently occurring distribution. So what is the most frequently occurring value in this table? It is 170. So 170 becomes my mode. Okay.